In this video, we are going to do one case-based question, and this case study question is based on coordinate geometry. What you can see, you may pause the video and read the information. So you can see over here, the picture is given over. These are the different position of the players given in a coordinate plane. And based on this, there are three questions. So four, in fact, including one or part. Let's begin with the first question. So if I type the first question over here, the first part says here that at an instant, the midfielders, forward midfielders, you can see there are one, two, three midfielders and one forward. So they form a parallelogram. So we are given that these are forming a parallelogram. That means if I join them, it should form a parallelogram, right? This is given over here. What we have to find out is the position of the central fielder D if the position of the other players formed are as this, like the position of A, B, C are given. So you can see from this information that we know the position of fielder A, B, and C, and we have to get the position of fielder D. So what we can do, let's say if I bring it down, and so that I can magnify and apply the property. Now, if I write down the coordinates over here, we know let's say if I write the way it is written, this is A, B, C, and the coordinate of D is what we have to determine. The coordinate of D we don't know, so this is what we have to determine. I can write the coordinates of A. The coordinate of A is given 1, 2 in the question. It is B is given as 4, 3, and the coordinate of C is how much? 6, comma 6. And let's say if I take this as x dash y dash. Now remember here the property we are going to use is not that opposite sides of parallelogram are equal. The property we are going to use is the diagonals of parallelogram bisect each other. That means here O is the midpoint of AC as well as BD. Now if I ask you how to get the coordinate of the midpoint, so you remember the midpoint formula, the special case of section formula. And what was that special case of section formula? If I type it, this is the formula. That is the midpoint of a line segment divided in the ratio 1:1. Then the x coordinate is obtained as what? X1 plus x2 over 2, and y coordinate as y1 plus y2 over 2. Right. So we can say that applying this formula, we can obtain its x and y coordinate. Right. So coming to this, if I find its the coordinate of O, considering O is the midpoint of AC, then you should say that it is x1, which is 6, plus x2, which is 1, divided by 2. And the y coordinate is what? X1 plus x2, that is 6 plus 2. That is 6 plus 2 divided by 2. Now, with respect to BD, right? Even O is the midpoint of BD, then you should say that the x coordinate will come as, say, x dash plus 4 over 3, and likewise its y coordinate will be y dash plus 3. So it's going to be y dash plus 3 over 2. But then you should know that these are only x coordinate, right? So this is x coordinate, so we can equate them. I repeat, this and this must be equal because they are x coordinate of point, same point. So I can say that x dash plus 4 over 2 should be equal to, this is 2, not 3, should be equal to 7 over 2. Right? This is 6 plus 1, that is 7. 7 over 2. So this 2 get cancelled. We get x dash as how much? 7 minus 4, which is 3. Now check for the y coordinate. Similarly, I can say that y dash plus 3 over 2 is equal to 6 plus 2 is 8 over 2. 8 over 2. This get cancelled and we get y dash as how much? 5. Now you may write down the answer over here. That is the required answer for the coordinate D, right? This is what we have to get. And what we got is this as 3 comma 5. 3 comma 5 is the answer for this part. I'll type the second part. Now in the second part, right, we are going to do the second part of that question. And what is it? It says check if the goalkeeper G, let me see where is the goalkeeper, that is goalkeeper G over here. and sweeper, this is sweeper, and K, which is wing back. They lie on the same straight line or not. So here we are not going to use that area of triangle property for proving being collinear or not, because that's not there in the class 10 CBSE syllabus. So we are going to use this concept that if say we have what are these line joinings, say G, H, and K, right? So you just have to figure out that if we'll be finding GH, we'll be finding HK, and we'll be finding GK. Irrespective of the order, if sum of any two is equal to the third, we say they lie on a straight line. One more time, we'll be finding the distance GH, HK, and GK using distance formula. And if any of the sum of any two, if it is equal to the third, we'll say that they lies on a straight line. So that's what, and we are going to use this formula called the distance formula in calculating. So what is that distance formula? Let's figure out. So distance formula, you must be knowing that it is, this is what the distance formula, right? That is, to find the distance between two, this is x2 minus x1 whole square plus y2 minus y1 whole square. So we are going to apply this formula to get this. So let's say if I know the coordinate, I know the coordinate of G as this. So I'm getting GH. GH should come as, applying this formula, this is x2 minus x1 whole square. So 3 minus 3, that is 6, right? 6 whole square plus y2. Y2 is 1 and y3, y1 is 5. So 1 minus 5 is 4, 4 whole square. So that comes out to be how much? This is under root 36 plus 16 is 52. And I can simplify them and write GH as how much? 4 into 13. So 4 will come outside as under root, outside the under root, and this will come as GH as this. Now, similarly, I'm going to get HK. So HK, the length HK will come as what? This is 0 minus 3 is minus 3, but minus 3 whole square is positive 9. And 3 minus 1. 3 minus 1 is 2. 2 whole square is 4. So remember, we are using this distance formula in this case. So HK will come as how much? Under root 13. And we have one more side to find out, and that is G with K, GK. So to get the length of GK, applying the same formula, it is x2 minus x1 whole square. X2 is what? This time is 0 minus 3. So it's positive 3 whole square, which is 9. And then 3 minus 5 is what? 2. 2 whole square is 4. So GK comes out to be under root 13. Right. So what you can figure out from here, that sum of, you can see from here that GK plus HK, right? Root 3 plus root 3 is equal to what? 2 root 3, that is GH. So we'll say yes is the answer, as they lie on a straight line. Now moving to the OR part of the second question. Now next is OR part, right? The OR part of second question. It says check whether the full back and central back are equidistant from forward. So where is forward? Forward is this, and we have to check full back. This is full back, and this is central back. We have to check whether this is equidistant from this or not. So we can figure out that we just need to figure out that whether J C is equal to IC or not. So we are again going to apply the distance formula to figure out. So let's say if I find JC, again applying distance formula, that is J and C, you need to see the coordinate of J over here and C over here. So it's x2 minus x1. So 0 minus 5 is what? Minus 5 square, that is 25. And 1 minus 3, that is 4. 4 whole square is 16. We are applying this distance formula. So JC comes out to be under root 41. Now I'll get IC for I and C. This is I and this is C and this is I, right? So 0 minus 4 is positive. 4 whole square is how much? 16. And then 1 minus 6 is what? Minus 5 square is 25. So IC is again under root 41. Yes, yes is the answer for this. They are equidistance. We are we got this as equidistance. Now there is one more extended part of this question is check whether C is the midpoint of I. So we are going to apply the midpoint formula, that is to x1 plus x2 over 2 and y1 plus y2 over 2. So C being the midpoint of ij, right? This is ij. So let's find out the midpoint of I and j. So it's going to be what? 5 plus minus 4 over 2 and second coordinate, these two. So it's 6 plus minus 3 over 2. Now to check it, what we are going to do, this is coming as how much? The coordinate here is how much? This is 1 over 2 and this is 6 minus 3 is 3 over 2. This is the midpoint of ij, right? But this is not same as C. Once again, you can see that we applied distance midpoint formula here. That is a special case of section formula. And we found that the midpoint of ij is coming as this, while the C is this. So definitely it is no. So for the extended part of this question, we'll say no, it's not the midpoint. We have one more part, that is third part. Let's do that. Now we have one more part, that is the third part. So what is that third part says? It says if the defensive midfielder, right? So we have this as a defensive midfielder, 1-4, that's A, right? And attacking midfielder, that is B over here, and the striker E. They are on a same straight line. So they are on a same straight line and they are equidistance. That means we have these two distance given equal. That is from here to here, it is equal to this. And what we have to find out is the position of E. So here too, we are going to use that midpoint, special case of section formula, that's called the midpoint formula. So we know that here the ratio is going to be 1:1. So what we can say that, let's say if I make a straight line, this is A whose coordinate is 1-4, right? 1-4. And that's B whose coordinate is 2 minus 3 and E whose coordinate is how much? AB. We have to get the coordinate of AB. So what we know that A, that is say x1 plus x2, say 1 over 2 should be equal to the x coordinate, which is 2, right? And likewise, we can say that B, which is this, plus say y1 plus y2 over 2 is equal to the midpoint of these line joining, that is -3. So from here by cross multiplication, what we'll get? A as how much? 2 into 2, 4 minus 1, that is 3. And B will get how much? 4 into 2 into -3 is -6. -6 minus 4 is -10. So we got the value of A and B. That's what we have to find, the position of E, and the position of E we will say now its coordinate is how much? That is x coordinate first and then y coordinate. So we'll say the position of E here, the position of E over here is -3, sorry, 3 minus 10. This is 3 minus 10. That's how we'll do this question.